Hello and welcome, everyone. What you're looking at here is a program I made on graph theory. So what I'd like to do is teach you some lessons on graph theory using this as a visual aid. So you can see here that I can select vertices and move them around. I can connect vertices or disconnect them by clicking on them or double-clicking on them. I can even create new vertices. And I can select entire components and connect them if I like to another vertex. And finally, I could even select a component and delete that if I don't want it anymore. So that's the basic functionality of my program. And what I'd like to teach you all today is a little pathfinding algorithm. So what I need to do first of all is create an interesting looking graph, and you can imagine this as being maybe a graph of a city. So these are vertices representing intersections, and these edges here represent streets you might drive on. And you're going to want to find a path to get from point A to point B. So something like Google Maps would be able to search through and find a way to get from one place to another. Although, of course, what we're going to do is a very simple algorithm. This wouldn't be exactly what Google does. Okay, so this looks pretty good. So let's say I want to get from this vertex in the upper left to this vertex in the bottom right. And this graph isn't so complicated, so you can do it visually. You can see I might just go here and then down and then over. But what we want to do is have the computer find it. So what we need is some sort of algorithm or some list of steps for getting from point A to point B. And I'm just going to explain to you what those are here. And mostly this channel is going to be about teaching math concepts, but I may teach you how to do some programming too, so I could show you all how to make this program, or possibly even just put the code up itself. Although the state it's in right now, it needs to be refactored pretty badly. Let's see. Maybe I'll do something like that so it looks a little more chaotic. Okay, that could be fun. So what I'm going to do first is I'm going to click a start, and it's kind of fun. I can still move these things around a bit if I want to. Okay, and then let's finish here. And I've given myself three options. These are the things I'd like to do to explain it. First is one step, so let's see what happens. We're going to begin at the start and try to get to the finish and take one step. And what it's going to do is look to see if the start is connected to the finish anywhere. So it's going to look this way, and it sees I can go here, and that's just one step. But that's not the finish, so let's try again. So what it's going to do is keep looking from the start, since there were other ways I could have gone. Maybe this was the finish. And of course it's not. So now it's going to take the paths that it's found, so it knows I can go here and start looking from there. Can I go from one to the finish? So take one more step, and from one I can get here, or I could go down here. Now from 2 there's nowhere new to look. I can go to 1 or to 4 or back to the start, but I've already found all those paths, so I want to go to the empty vertices. So it'll skip over 2 and go to 3. And then from 3 it found 5 and 6, but that still didn't make it to the finish, so now it's going to go to 4, and from 4 it'll step over to 7, and then it will continue from 5, so from 5 it finds 8. It looks like there's one new one from 6, so 6 is going to be able to go down here, so that's going to be number 9. And then 7 is going to go over here, that's going to be number 10. And then 8 can explore here, so that's 11. There's nowhere new to go from 9. Everything's been explored. So we're going to skip 9 and go to 10, and 10 can find the finish. So what it's going to do is it's going to step to the finish, since it already is going to look and see is it connected to the finish, and yes it is. Then it's not going to care about all these other paths it explored, because what we're really looking for is just how to get from start to finish. So all the other stuff is going to go away. And there we go, there's a path to get from start to finish that you can run in a computer algorithm. So let's try this again and get from maybe this vertex over here in the top right to this vertex down here in the bottom left. So we're going to start up here and then end down here. And this time I'm just going to animate it. So if you watch, you'll see it do exactly the same sort of steps. It's going to start here and then look in all directions from the start. So tries this one and this one and that one and that one. And this was the first one, so it's going to try everything from 1. Then it tried everything from 2, and so on. So you see it exploring the graph and exploring until it finally finds the finish. Okay, so that's pretty cool. Maybe one more time. Now, of course, these aren't the most efficient. This isn't possibly the most efficient algorithm. There might be a smarter way to do this, but it's certainly working. So here, if we just went to this vertex and to this vertex, we'd be done. But the computer isn't looking at the entire graph. It's only looking at where it is, and then it's trying to explore and find its way to the finish. So, oops, let's animate it. Okay, so it looks all around. And I tried 1 first, so it tries that, and then finally it sees from 2 I could find the finish. But computers are really quick at doing these sorts of things, so we could just have it not animate anything for us, and I could say quick. And what's going to happen here is it's going to search just like it has been. So it's going to take the start, look at everything the start's connected to, and then go from those, and then explore one step at a time. However, it's going to happen so fast that you don't even see anything, it's just, it finds a path. So maybe let's do that again. Pathfinder, let's see this path again from here to here. Just real quick, that's the answer. Okay, so that's a simple pathfinding algorithm. There are other algorithms, but I think what we're going to do next is look at some cool applications of this.